This video I want to continue with the concentration of solution. In the first part we saw the definition of concentration and how to calculate the concentration in terms of molarity, and we said molarity is the number of moles of solute per volume of solution, and solution consists of solute and solvent. Solute is dissolving into a solvent. So solution concentration, the amount of solute in a solution is variable. A dilute solution is a solution that contains a small amount of solute relative to the solvent, and a concentrated solution is the solution that contains a lot of solute relative to the solvent. So when we have less amount of solute, we call it a dilute solution, and when we have a large value or large amount of solute, we call it a concentrated solution. So as you see here, on the right hand side we have the dilute solution. As you see here, we have a lower number of solute we have in the solution, and on the left hand side we have a concentrated solution, which we have a lot of solute dissolved in a solution or dissolved in a solvent. So let's have some examples. If 25.5 grams kBr is dissolved in enough water to make 1.75 liter of solution, what is the molarity of the solution? So we said molarity is the amount of solute in terms of moles divided by volume of solution. So here the volume of solution is given, and we have the amount of solute in terms of grams. So first of all, we need to divide it by a molecular weight of kBr to find the number of moles, which is going to be 0.21429 mole kBr, and volume of solution is given. So 0.21429 per 1.75 liter is going to give us the volume, the molarity, which is 0.122 molar. Next example, how many liters of a 0.125 molar NaOH solution contains 0.255 moles of NaOH? So here in this example we have the concentration and we have the number of moles. So we need to find the volume. So in this case we need to multiply the number of moles times inverse of concentration. So here we have the number of moles of NaOH, sodium hydroxide, and here we need to multiply by inverse of concentration, which is 1 liter per 0.125 mole sodium hydroxide. So if we cancel these two, we can find the volume of solution, which is 2.04 liter. Next example, a 5.623 gram sample of NaHCO3 is dissolved in enough water to make 250 milliliter of solution. We need to find the molarity. So here we have the amount of solute in terms of grams. We need to divide it by molar mass or a molecular weight to find the number of moles of solute. And here we have the volume of solution. It is given in terms of milliliter. We need to convert it to liter. It means that we need to divide it by 1000. So here we have 5.623 grams. We need to divide it by molar mass of NaHCO3, which is 84.01. So the number of moles is 6.693 times 10 power minus 2. So molarity is 6.693 times 10 power minus 2 divided by 250 milliliter, and that's the conversion factor to convert milliliter to liter. So we have 0.2677 molar NaHCO3. So instead of this conversion, we could just write 0.25 liter. Next example, a 1.184.6 milligram sample of K2Cr2O7 or potassium dichromate is dissolved in enough water to make 500 milliliter of solution. So here again we need to find the concentration or molarity. We have the volume of solution in terms of milliliter. We need to convert it to liter. So if we divide it by 1000, we can say 500 divided by 1000 is going to give us 0.5. And here we have the amount of solute in terms of milligram. We need to convert milligram to grams and then grams to number of moles. So 0.1846 grams potassium dichromate times 1 mole per 294.2, which is molar mass, and we can find the number of moles of potassium dichromate. As I said, we have the volume of solvent, so we can find the molarity. Next example, a 0.1025 grams sample of copper metal is dissolved in 35 milliliter of concentrated nitric acid to form Cu2+ ions, and then water is added to make a total volume of 200 milliliter. So this total volume 200 milliliters. So we need to find the concentration of copper in the solution. So we have 0.1025 grams. If we divide it by atomic mass of copper, which is 63.55, we can get the number of moles of atomic copper, which is 1.613 times 10 power minus 3. And all of them, when we dissolve it in nitric acid, is gonna get, all of them is gonna convert to ions. So we have 1.613 times 10 power minus 3 moles ionic copper. So we have the number of moles of copper, and we have the volume of solution. So if we divide the number of moles by solution, but be careful here where the volume is in terms of milliliters, so we need to divide it by 1000, or we can have this conversion factor. So it is going to be 8.065 times 10 power minus 3 molar copper. Next example, what mass of NaOH is contained, NaOH or sodium hydroxide is contained in 250 milliliter of a 0.400 molar sodium hydroxide solution. So here in this example, we have the concentration and we have the volume of solution. And we have the volume of solution in terms of milliliters, so we need to convert it to liter. And then we can find the amount of NaOH. So we have the concentration. If we multiply it by volume of solution in terms of liter, we can find the number of moles of solute. And then number of moles of solute, we need to multiply it by molecular weight to find the mass of solute. So here the molar mass of NaOH or sodium hydroxide, if it's not given, it is Na is 22.99 or 23, O is 16, and H is 1.008 or 1. So the molar mass is going to be 40 grams per mole. So mass of NaOH, here we have volume, which is 0.25 liter or 250 milliliter. If you divide it by 1000, it's going to be 0.25 liter times the concentration, 0.4 mole per liter. So that's the product of the first two items is going to give us the number of moles of solute or number of moles of sodium hydroxide. If we multiply it by a molar mass of NaOH, which is 40 grams per 1 mole, we can get the amount of solute or amount of sodium hydroxide, which is 4 grams.